We have the equation x squared plus 1 equals 0, and we want to find the solutions. If we take a look at the graph of the equation, we can see that the parabola never intersects the x-axis. Therefore, we can say that there are no solutions. So let's actually try to simplify the equation and see if we get anything different. X squared equals -1, and so our only option from here would be to take the square root of both sides. So we're left with the square root of -1. But we know we cannot do that because, so let me just clarify that we want -1 as a result. If we take 1 times 1, we get 1, which is not -1. Likewise, if we take -1 times -1, we get 1. Two negatives make it positive. So this is also not what we want. So due to problems like these, mathematicians have come up with a new unit, the imaginary unit, in which we say that the square root of -1 is equal to some imaginary number that will let us complete this equation. So in other words, if we have x squared equals -1, and so x equals square root of -1, we can rewrite the square root of -1 into x equals I. So some imaginary number I times itself will give us -1, which is our original goal. We know that the square root of -1 is equal to I, which we call our imaginary unit. So knowing this, let's simplify some square roots that involve negative arguments. We know from our square root properties that the square root of -25 is simply -1 times 25, the square root of that. And as such, we can break it down into two square roots. Square root of -1 times square root of 25. And we know that the square root of -1 is simply I. And we know that this simplifies to 5. So our answer would be 5i. Alright. The square root of -4. Again, we can break this down into the square root of -1 times the square root of 4. Let me color scheme this. And from here, we can break this down into two square roots. Square root of -1 times square root of 4. Once again, we know that this square root of -1 simplifies to I, and that square root of 4 simplifies to 2. So our answer would be 2i. Square root of -16. Again, break this down into -1 times 16. Break this down into two square roots, -1 times square root of 16. We know that the square root of -1 is I, our imaginary unit. Square root of 16 is 4. Therefore, our answer is 4i. And for any number that is negative x, we can simplify this into -1 times x, meaning that we are left with two square roots, square root of -1 times square root of x. And so we know that the square root of -1 is I, and then we simplify this however much we can, and as such we're left with I times the square root of x. We know that I equals the square root of -1. So let's write this down. I to the first power, right, same thing, equals square root of -1. So what if we were asked to find I to the power of 2, or I squared? We know that this is simply I times I. And as we have previously stated, I is equal to the square root of -1. So in other words, we have square root of -1 times square root of -1, meaning that I squared is -1, because I is equal to the square root of -1. So, if we use this information and we want to find I to the third power, we know that this is simply I squared times I. So let's simplify. We know that I squared is simply -1. So we will write down this -1. And we know that I is the square root of negative 1. So let's write this down. Square root of negative 1. What does this leave us with? We're left with the negative square root of negative 1. The negative square root of negative 1. And as we know that the square root of negative 1 is I, we're ultimately left with negative I. Negative I is the result of I cubed. So what if we take I to the fourth power? I to the fourth power is simply I cubed times I to the first power. So let's simplify this. We know that I cubed is negative I. Negative I, and we know that I to the first power is simply I. Simplify this and you're left with negative I squared. So negative I squared. We know that we know that I squared, if we rewrite it like this, we know that I squared is simply negative 1. So the problem we're asking is really negative negative 1. So our answer is 1. And these are the basic powers of I. So what if we had I to the fifth power? We know that I to the fifth power is simply I to the fourth times I. And from this chart, we can see that I to the fourth equals 1. So in other words, we're simply doing 1 times I, meaning that we're left with I. So it goes back here. So let's do I to the sixth power. We know that I to the sixth power is simply I to the fifth times I. Therefore, I to the fifth is I, and I is simply I. So we're left with I times I, or in other words, I squared. And with this chart, we know that I squared equals negative 1. So we're left with negative 1. And you will notice soon that the powers simply repeat when you keep raising it. So for instance, I to the seventh is simply I to the sixth times I. We know that I to the sixth is negative 1, and I is simply I, so we're left with negative 1 times I. In other words, negative I, corresponding to I to the third power. And finally, I to the eighth power is simply equal to I to the seventh times I. We know that I to the seventh is negative I. And once again, we're left with the same problem in our original expressions, meaning that negative I squared is simply 1, or I to the fourth. We know that I to the 5 simply reduces to the first, 6 reduces to 2, 7 reduces to 3, and 8th power reduces to 4. So what can we conclude? Whenever we have a power above 4, we simply subtract 4, and we would be left with the original 4 powers. The original 4 powers. Using this information, we know that if we subtract 4 from I to the 9th power, we would be left with I to the 5th power, which we already know is equal to I to the 1st power. Likewise, I to the 10th power, we subtract 4 from that, and we're left with I to the 6th power, which we already know is I squared. I to the 11th power, we subtract 4, we're left with I to the 7th, which we already know is I cubed. And finally, I to the 12th power minus 4 is I to the 8th power, which we already know is I to the 4th. Given a power of I in which x is greater than 4, so this can be I to the 5th, I to the 6th, etc., we simply take the remainder of that number when divided by 4, and this will return us to the original 4 powers of I. So again, our goal is to take the remainder of that power, and we will see what I mean in just a second. So we want to simplify powers of I in which this exponent is greater than 4. So again, we want to take the exponent and divide it by 4 and take its remainder. So 4 goes into 35 8 times. We're left with the remainder of 3. What does this mean? I to the power 35 simplifies to I to the power of 3, which we know is negative I. So this would be our final result. I to the power 42. So in other words, we take 42 divided by 4, and then we can't do this, so our remainder is 2. In other words, I to the 42nd power equals I to the second power, which we know equals negative 1. So 73 over 4, simplify, our remainder is 1. So I to the power of 73 equals I to the power of 1, or just I. So this would be our final result. And finally, I to the power of 104. 4 into 104. So 2, 8, 2, 24, 6, 24, and our remainder is 0. This means two things. I to the power of 104 is equal to I to the power of 0, or as we better know it, I to the power of 4. So, why is this? I to the power of 0, we know that any number to the power of 0 is simply 1. We also know that I to the power of 4 is simply 1. So at the end of the day, regardless of which one you use, you can say that this is equal to 1.